Hi everyone, and welcome to the HYPACK LiDAR Payload webinar. My name is Brittany Hines, Marketing Specialist here at HYPACK, and I will be your host for today's presentation. Before we begin, I just want to remind you about the question box on the side of your screen. We will be taking questions at the end of the webinar, so please submit them there. Also, if you're unable to hear us or the screen goes blank, please comment in the chat box so we can fix the issue. For today's webinar, we are going to talk about our new solution, the HYPACK LiDAR Payload, and how it can better your survey work. I would now like to introduce our presenter for today, Hannah Marshburn, who is our sales representative and unmanned systems lead here at HYPACK. We are so happy to have her here with us today to talk more about this new solution. So with that, I'm going to turn over the presentation to Ms. Hannah Marshburn.
Hi everyone, thanks for joining us here today. We're excited to share with you our new solution and tell you a few of the ways that we're trying to keep up with all of your LiDAR surveying needs. So as you may know, HYPACK has supported LiDAR products over the past few years. The payload is a culmination of all the things we've learned while doing so. The drone industry and the LiDAR industry and the unmanned system industry continues to rapidly advance, which makes it difficult to stay current on what products are new and what products could work for you. HYPACK's focused on making good and dependable products that meet your needs without being super overwhelming. We're confident that the payload will be a great solution for our customers, and we're excited to share it with you. To start off, let's talk a little bit about the incorporation of LiDAR into hydrographic and topographic surveying. Here's a few reasons why it's become so popular. LiDAR is a great way to capture difficult to obtain data. During dangerous shoreline acquisition, where boats previously may have had to approach rocky or unsafe areas, you can easily mount a LiDAR onto your boat and capture that data from a safe distance. It's also a great way to collect data in areas that have dense vegetation or other hazards that are hard to travel over. LiDAR is really good for picking up thin edge features. If you need to survey using LiDAR on a UAV and you're trying to look at some power utilities or other sorts of thin features, it can pick that up really well in comparison to other surveying methods like photogrammetry and other types of remote sensing. As I just briefly mentioned, LiDAR also can penetrate through forest canopies and dense vegetation, so it can be really helpful to do those sorts of biomass or more vegetation-oriented studies. It also integrates really well with our other sensors and hydrographic surveying workflows. A lot of the data formats are really compatible, so you can use it easily with your already existing hydrographic setup. LiDAR does not require a lot of processing, so there's a quick data turnaround, which is great for your customers and great for your employees because it's easy to work with. And it's also very low cost compared to running a survey boat or other planes. So overall, it's a really efficient way to collect data quickly, and it reduces a lot of risk. I'm going to briefly talk you through how we support LiDAR surveying in our HYPACK software. This may be a reminder for those of you who are already familiar with this workflow, and hopefully a brief introduction into some of the ways that we've come up with tools to support LiDAR surveying in HYPACK. So first of all of your mission planning tools in HYPACK are available to you if you need to conduct a LiDAR survey. For the purposes of the payload, things are working a little differently. The payload will operate completely independently of your autopilot or navigation system, meaning that HYPACK will not send commands to your system. So if you need to plan a mission for LiDAR using the HYPACK LiDAR payload, you're simply setting up lines or waypoints for areas you would like to collect data. You will not be controlling the mission from the HYPACK shell. But nevertheless, all of our survey planning tools are available to you. So similar to setting up a hydrographic survey in HYPACK, you need to set up your hardware settings. For the LiDAR payload, our sensors are the Velodyne VLP 16 and an SBG INS system. So you would need to add those devices into your hardware settings and enable HYSWEEP, which is what you will use to collect data for the LiDAR payload. Once that's all set, you need to launch HYPACK Survey and HYSWEEP. The survey program will help you display your data in real time, and all of the same tools that you would use for a hydrographic survey are available to you. You can use the Matrice to monitor your coverage in real time, and any GPS device drivers to monitor your GPS in real time. Another special driver we have for LiDAR systems is our topographic laser device driver. Here you can monitor your data, monitor elevation in real time, and set a few interactive filters like our range and yaw angle filter. We also have a great real-time cloud interface. The real-time cloud interface allows the user to see real-time geo-referenced motion-corrected data as it's recorded. You can set your display colors to show depth, elevation, or intensity values recorded from your LiDAR unit. We also have a suite of targeting tools where you can mark points of interest and save that out to a database. Our remote viewing platform is really helpful for unmanned systems applications. It requires a secure network connection, which you would have to attach to the payload. But through a web browser, it allows you to observe and interact whatever autonomous operations you're conducting. You can view your vessel position, manually control logging, and monitor your mission. It requires just a secure connection and a web-enabled device, and you can simply access this through a browser. Now I'm going to talk you through a brief description of the tools available to you in HYPACK to process your LiDAR data. One of the first things you might want to do is use our Data Splitter and Joiner tool. It's accessed right through our shell under the Utilities tab. Through this tool, you can post-process data collected autonomously and log continuously. You can remove your turns and any data points of error that your turns may have introduced and create traditional looking track lines. This is really helpful for drones and UAV surveying, but it also is a great application to use for the payload. So after you have the desired track lines, you can load that data into MBMax 64. Those of you that are familiar with MBMax and may process your multi-beam data in it, it's our main processing engine for multi-beam and LiDAR. And here you can apply filters, edit any flyers, and perform sensor calibration. We also have a few specialized LiDAR filters that are accessed here through the shell. So one thing to note is that it's important to remember to perform a patch test calibration and set those patch test values in your read parameters. Two of the tools we have available to you so you can edit your data points are Profile View Window or Real-Time Cloud. All of the flyer editing tools are going to operate the exact same as they would if you were editing hydrographic data. We also have a few tools that help you smooth out any GPS data, especially if you collected that from a drone. You also can apply SBETs to your data to achieve PPK level precision and set depth or elevation mode. So with the INS GNSS system we're using with the payload. It's the SBG Ellipse 2D. They have a recommended mode for filtering GPS data. So here in our search and filter options, which are accessed through MB Max, you can click enable accepted GPS modes under position and just type in 7. And this can be a really helpful way to keep your GPS data as clean as possible. And while it's important to note that LiDAR data is generally pretty clean of spikes we have in a multi-beam sonar survey, it's still really helpful to keep an eye on your GPS. Also in search and filters, as you can see on the right side of the screen, you can set a minimum and maximum corrected depth or elevation, which just simply acts as a gate and filters data outside of elevations you may not want. So you can filter out, if you're using a UAV, data that was collected while the craft was ascending or descending, and only keep data collected at specific survey altitude. Just to reiterate, if you filter GPS data based on mode value, it's important to check settings to delete soundings between deleted position points so bad GPS data won't affect the quality of your product. LiDAR data is not interpolated like sonar data, so if you have areas of bad GPS, you will likely have a gap in your survey. It's just something to keep an eye on in HYPACK, and hopefully we have tools that can help you monitor your GPS in post-processing. So we have a few windows that'll help you work and clean your flight sensor data if you need that. Our tide window allows the user to look at your flight data so you can see if you have any elevation spikes. That's the top window on your screen. And if you see any elevation spikes, you can simply edit them out. In the middle window, we're showing you the pitch and roll window, which allows you to look at data from your IMU and edit out any spikes if necessary. And the third window is a speed window. So again, you can QC any flight speed spikes. Here is our vegetation filter. Now, this vegetation filter is accessed through the profile window. You just have to check enable vegetation filter and this dialog box will open for you. So the vegetation filter differentiates between ground level and potential vegetation by recording the minimum elevation and then interpreting that as ground level. There are 3 active ways to control the filter: the window size, which is the along profile segment distance, the overlap percentage, which is the overlap between the window segments, and the gate size, which simply sets a gate and filters out anything outside of the elevations of your gate. It's important to keep in mind the difference between these 3 active filters so you have a representative sample size. The vegetation filter can be really helpful if you're trying to do a specialized study either on the ground level or on the vegetation height, and can be good for gauging the general elevations of vegetation nearby. Here's an example of the vegetation filter deployed on a data set. As you can see in the top left corner, this data set had vegetation of varying heights as well as buildings. We use a vegetation filter to filter those out. The folks in this study were investigating some soil irregularities. And on the bottom right corner, you see that the buildings and trees were successfully filtered out. Another specialized tool we have for you is our tin stockpile volume tool. This tool allows the user to quickly compute volumes of areas using a border file. You can measure multiple stockpiles at once using individual border files. As you can see in this graphic, you get a calculated area of the stockpile volume. in a few different ways, as well as a really helpful report. To begin stockpile volume, a border file is required. The tool then interpolates a tin from the border file and performs a tin-to-tin comparison, quickly computing the volume of the areas in focus. As you can see, the tool also produces a really helpful report where each pile is computed separately, and it tells you the volume, the void, the perimeter, and the area for each border. You can save this out to a PDF or a text file. This tool has great applications for beach erosion surveys, construction site volume estimations, work at quarries, and other types of tools or applications where you would need to compute the area quickly. We have a few different final products for LiDAR data, and I'm going to walk you through these quickly before we get into the specifics about our new payload product. So one of the exciting things that you can do in our real-time cloud is import GeoTIFFs. We take the RGB colors and apply them to your XYZ file, which produces a realistic looking point cloud. You can always save your data set out to an XYZ or an LAS, and we hope that you use this tool to produce XYZ point clouds that look great. A few of our other exportable products are an AutoCAD DXF format, so if you need to continue to do analysis in AutoCAD, and then a portable web cloud format, which simply gives you a browser link so that someone who doesn't have HYPACK can look at the data set just simply using their browser. Okay, it's time to talk about the payload. So our payload is a great standalone LiDAR solution that was designed to fit the needs of our customers. It's an industrial surveying tool, and it has everything you need from start to finish for a LiDAR survey. Inside this enclosure, we have a computer running Windows 10 with a HYPACK Max HYSWEEP software program on it. As you can see, the Velodyne VLP Puck Lite LiDAR is hard mounted onto the front of the case. Inside the unit, there's also an SBG Ellipse 2D dual antenna compact INS system with an integrated dual antenna survey grade RTK capable receiver. There's also an internal battery that has a 3-hour runtime. The battery is also small and light enough to be carried on and flown with commercially, so you won't have to worry about shipping restrictions. The enclosure itself is IP67 rated, so it's dust and weatherproof and can even be submerged up to 1 meter in water. You can also note that the antenna arms have brackets that are attached to the side of the unit, which allows them to extend and retract for easy transport and setup in the field. Our payload unit will also come packaged in a Pelican case for secure transport that includes a set of spares. You can also see that on the top of the unit, there's a metal brace with 4 clamps. Those 4 clamps are designed to fit on a UAV of your choice, which I'm going to talk a little bit more about the next slide. We also have brackets that will help you attach the payload to a car or a boat and a stand so the payload can rest well on a flat surface. The payload is a fully contained LiDAR solution. As we talked about, it has an internal battery, so it does not need to attach to anything. It can run completely by itself. When the antenna arms extend, they snap into place at a fixed offset of 1 meter, which eliminates the need for repeat heading calibrations. So if you need to do a GAMS or a heading calibration, you only need to do it once. Save those offsets into HYPACK and the SVG software, and you shouldn't need to calibrate it again. As I mentioned, it can go on any vehicle platform. It's designed to fit on UAVs, but it can also go on boats, cars, backpacks, whatever you need. The total weight of the system is 7.5 pounds, and it can fit on any drone that can lift 7.5 pounds or over. Here's a list of a few companies that make drones that can lift 7.5 pounds. The VLP Puck Lite is the sensor we've chosen to go on the front of the payload. It's a very common and popular LiDAR unit, easy to use, accurate, cost-effective, and has become almost a standard in hydrographic surveying. It has 16 channels, a range of up to 100 meters, accuracy within 3 centimeters, a weight of 590 grams, dual return modes, and it's Class 1 eye-safe, meaning you don't need any specialized personal protective equipment to operate this unit. We have a special Velodyne driver in HYPACK for this. As you can see, there's 16 channels that can be activated or disabled. We have a range filter where you can set minimum and maximum elevations, filtering out lower elevations that may introduce noise or any sort of reflection you may get if the sensor is hard mounted on a boat and you're getting reflection off the boat deck. This filter can be really helpful for that. We also have an angle filter. You set minimum and maximum angles, and the filter keeps data within those specified angles. The Ellipse 2D Mini INS system is a compact inertial system, super lightweight, so it's great for UAV applications. It can measure roll and pitch to within 0.1 degrees, can measure heading to within 0.2 degrees, has a real-time heave filter that can record heave up to 5 centimeters and is RTK capable and can calculate position to 2 centimeters. Is a 200 hertz output rate and a 2-year warranty. The payload is configured to support PPK, so you can record your GNSS data, and then SVG offers a post-processing software called Inertia. We'd be happy to provide you with more information about that, so you can achieve PPK level data using the payload. Here are some examples of data collected with our LiDAR solutions to give you an idea of the system's accuracy. This was collected at an altitude of 20 meters right here at our HYPACK facility over surface with moderate reflectivity, an area with vegetation, grass, and soil. And if you can see in the bottom image, the vertical uncertainty was pretty evenly spread for the whole test study to within 5 centimeters. In our next slide, on this same test flight, we collected data in a spot adjunct to the soil grassy area where the last data set was collected. This is collected over black asphalt, same altitude, 20 meters. And asphalt has a low reflectivity, high absorption rate, and this caused the average vertical uncertainty to jump up to 9 centimeters. So this gives you a pretty good indication that the data quality will be directly related to the surface on which you're collecting data. Surfaces with moderate and high reflectivity will give you a lower average vertical uncertainty, and surfaces with low reflectivity and high absorptive properties will give you higher average vertical uncertainties. Here's a picture of the payload mounted to a DJI Matrice 600, which is one of the most popular industrial drones used in surveying. As you can see, the payload is simply mounted to the carbon fiber rods underneath the DJI. The extendable arms are in place at exactly 1 meter separation, and the antenna arms sit underneath the propellers and the antennas of the DJI, so there's no interference there. The antenna arms are also in front of the legs of the DJI, which extend and retract when the system is being flown after takeoff and landing. So there's an easy way to mount this system to the DJI. You just simply mount the 4 clamps to the carbon fiber rods, secure those in place, start your payload mission, and you're off. Again, to note that the payload will not be controlling the mission or sending waypoints to the device. It'll simply just be logging your LiDAR data, so you only have to worry about monitoring the flight data through the DJI drone. Here's a picture of the back panel of the LiDAR payload. So as you can see on the left, there's an available USB port for your HYPACK key. You can also take off the back panel and fit a mini USB key inside of the unit, freeing up that USB port for other uses, like if you wanted to attach your micro camera to take pictures for photogrammetry or georeference imagery. That's a great spot for it. We also have an Ethernet port, as you can see. You can use this port to connect the payload directly to your personal computer to initialize software for the SVG, the Velodyne, and to initialize HYPACK. You can mission prep in HYPACK and start logging your data. This Ethernet access gives you easy access to your data and your mission. The PPS port on the far right is bringing timing out from the SVG, which could be brought in as timing for other instruments you're surveying with if needed. Not pictured is a power indicator located next to the on and off switch. The unit has a 3-hour runtime. The power indicator can help you monitor your power usage throughout the 3-hour runtime. If needed, this back panel can also be removed. You'll find that the SVG and the mini computer are mounted on a rack that slides out for easy access. We hope that you don't have to troubleshoot the product, but in the case that this might happen, this panel and sliding rack provide easy access for troubleshooting in the field. Here's a sample data set that was collected with the payload mounted on a truck in Canada by our tech support manager, Jerry Nisley. As you can see, it picks up the thin-edged feature of the power line and the utility poles quite well as giving you a distinct outline of the vegetation. Here's an image of the same data set brought into MBMax, our processing engine, overlaid onto GeoTIFF exported from Google Earth. As you can see, you can clearly denote the ground level, the height of the trees, the power line, the width of the road, and the other features that were in question during this study. Here's another vantage of another piece of the data set that was collected in Canada recently by Jerry Nisley. In this picture, you can see that the Velodyne picked up the surface roughness of the grass quite well, which gives you an indication of the level of detail you can get using this system. So in summary, here are our payload benefits. It's an extremely easy to use turnkey solution. It has a runtime that will increase your mission efficacy and cause very little user interaction. It's versatile. We are confident it could work well in your hydrographic surveying workflow and your topographic surveying workflow, and hopefully be an easy introduction if you're looking into getting into unmanned surveying, either attaching this to a surface vehicle or a drone. It's cost effective. We're well aware that LiDAR surveying is really expensive and that cost can be daunting. So we're aiming to keep this as cost effective as possible so we can better support you, our customers. It has a familiar interface for our HYPACK users, so you don't have to learn a lot of new tips and tricks. And we're happy to keep working with you and getting feedback and making our interface as good as possible. The antenna arms and their fixed offsets make for easy setup and initialization in the field, reducing the need for repeat calibrations that often you have to do if you're using a LiDAR UAV system. And again, the 3-hour runtime is a huge bonus. It helps increase your time in the field and keeps things rolling. And it's a great, accurate LiDAR solution. A few of the potential applications we developed this payload for are shoreline or obstruction charting for navigation. Again, getting away from using cumbersome methods like navigating a boat close to a rock to try to get the height and position. With the payload, you can use LiDAR to shoot that rock and get a height and position from a safe 100-meter range distance. We have folks that are using our products to do some pipeline mapping in Canada. It's great for infrastructure assessments, calculating volumes and looking at beach erosion, doing beach erosion surveys, any sort of vegetation survey that the payload would be appropriate for, looking at bare earth and doing some soil roughness analysis, and corridor mapping.
Thank you, Hannah. That was a great presentation. We hope that this gave everyone a better understanding on how the HYPACK LiDAR payload works and how it can better help your projects. Now, before we begin the Q&A, I just want to remind everyone to register for our annual training event, HYPACK 2020. You will be able to see the payload at the event and learn more about it and get to talk with Hannah about this new solution. At the training event, we will offer instruction on the newest features of HYPACK 2020, as well as training for both novice and experienced users in HYPACK, HYSWEEP, and DredgePack software. And the event will take place in Jacksonville, Florida on January 6th to the 9th, 2020, so we hope that you join us. So now we will move into the Q&A section of the webinar, and we hope you stick around for this section, but if you're unable to, we want to thank you for joining us today, and we hope to connect with you in the near future about the HYPACK LiDAR payload solution. We're going to try to answer all of the questions, but if yours goes unanswered, we will follow up with you via email over the next few days.
So our first question is does the payload support RTK? The payload is RTK enabled completely. You would need a mobile Wi-Fi receiver and some long-range antennas that are capable of supporting a Wi-Fi connection. And here at HYPACK, we're working on putting an optional kit together that would provide for you different options for RTK and a base station. Next question, can the onboard computer support other data collection types and software programs? The computer we're using is a Pico Mini PC 500, and we've put some extra RAM in there, so it's definitely capable of collecting data for the entirety of the payload's runtime, the 3 hours. You can load other software programs on there. We're working on attaching cameras, so folks interested in photogrammetry can collect data. And we're certainly open to working with you, but we're confident in the capabilities of our computer. Next question, are we able to accommodate other sensors than the SPG and the Velodyne Puck Lite? At this time, the payload's configured to support those specific sensors. But if you let us know your concerns, or if you have a really specific application or a specific set of sensors, we're open to working with you, especially if it fits with the physical requirements of our payload. So please send us your interests or send us your applications, and we would be happy to work with you. Next question. I already have a HYPACK Max and HYSWEEP license, and I don't know if I need another one. Can I use my already existing license? You can, and we are happy to accommodate you. If you already have a HYPACK Max and HYSWEEP license and are interested in the payload, please let us know, and we will work with you and accommodate you in our price line. Next question is, what weather requirements must be observed for the correct operation with this system? With the IP67 rating, the enclosure itself is dustproof and waterproof, and apparently can be submerged in water, but it's important to note that the antennas themselves and the LiDAR sensors are sensitive to inclement weather. So while you can mount the payload on a boat and use it outside, I would just use your common sense. Any sort of torrential downpour or extreme wind might not be great weather to operate the payload. We've worked really hard to stabilize the antenna arms, so in high winds, those shouldn't be affected. So I would say it's rated for inclement weather, but still to use good judgment. Next question, how deep can the laser penetrate into the water? So technically, if there was pristine environmental conditions, it would be able to penetrate to very shallow depths, but the Velodyne is really just a topographic LiDAR system, so we wouldn't recommend using it as a bathy LiDAR system. Next question is, to measure the offsets, will it be from the course over ground of the drone or the payload? The offsets would be for the payload, so they'd be measured to the center point of the INS, which is inside of the payload. Again, if you needed to look at that, you could undo the back panel, slide the rack out, mark the center point of the INS system, and calculate the offsets from that point. We're working on putting an easy pinpoint on the top of the unit, so you wouldn't have to do that, and you'd be able to have a good visual reference for the center point of the INS, but the offsets would be on the payload. Next question, is the Velodyne capable of nearshore shallow water surveying in clear water? To reiterate on the other question that was similar to this, theoretically the green wavelength should be able to penetrate in pristine environmental conditions to very shallow depths, but the Velodyne is really intended to be used as a topographic LiDAR system. But if anyone's really keen on trying, please let us know. And if you get great results, we'd be happy to share that with other folks and support you in that. Next question, what is the max surveying distance from the survey object? So the LiDAR has a range of 100 meters. I would say that the optimum range for this system is probably 50 meters and closer, but you should be able to collect data from 100 meters. So if the survey object was 100 meters away, you should be able to collect data from that point.
Okay, everyone, we're unfortunately out of time, so we're going to wrap this up. And we want to thank you all for your participation and hope you enjoyed the webinar today. We will get in touch with anyone who had unanswered questions over the next week. And please do not hesitate to contact us. We can be reached at sales@hypack.com. And don't forget to check us out on Facebook and Twitter and LinkedIn for upcoming news and updates. We hope to talk to you soon and hope you have a great rest of the day.